Priyanka. Today we are going to solve a problem on turning moment diagram and flywheel. In this video we are going to learn how to draw turning moment diagram when the equation of torque is given. We are also going to use simple basic formulas for calculation. Now first I will read what is the given problem. The turning moment curve for an engine is represented by the equation T is equal to 20,000 plus 9,500 sin 2 theta minus 5,700 cos 2 theta Newton meter, where theta is the angle moved by crank from inner dead center. If the resisting torque is constant, find out first power developed by the engine. Second, moment of inertia of flywheel in kilogram meter square if the total fluctuation of speed is not to exceed 1% of mean speed, which is 180 rpm. Third, angular acceleration of the flywheel when the crank is turned through 45 degree from inner dead center. So this was the given question. Let us first understand how to draw the turning moment diagram. So for that we have to first find out the mean torque, because we have to plot the areas above the mean torque and areas below the mean torque. So how to find out? We have torque equation T is equal to 20,000 plus 9,500 sin 2 theta minus 5,700 cos of 2 theta. Now we know that what is the work done per revolution. So we will consider here for one revolution, that is angle covered is equal to 2 pi. So work done per revolution is equal to, we have to give the limit. So limit from angle 0 to 2 pi, and work done is nothing but torque multiplied by d theta. So integration of 0 to 2 pi t d theta. So this is the equation to find out the work done per revolution. So this equation is important. So we have to give the limit. So this limit we will consider here for one complete revolution of the crank, that is total angle covered is equal to 360 degree, and that is nothing but which is equal to 2 pi. So we will give here the limit from 0 to 2 pi t d theta. So in one complete revolution, what is the work done? So for that we will write here equation, that is the equation of torque in terms of theta, that is 20,000 plus 9,500 sin 2 theta minus 5,700 cos of 2 theta bracket complete d theta. Now if we observe this integration 20,000 d theta, that means 20,000 theta, then next term is sin of 2 theta d theta. It is having integration, that is minus cos of 2 theta by 2. So 9,500 remains constant. So we will write here minus 9,500 cos of 2 theta by 2. And next term is cos of 2 theta d theta. So it is having integration sin of 2 theta by 2. So we will write here minus 5,700 sin of 2 theta by 2, and limit we have to give outside the bracket 0 to 2 pi. Now here instead of theta we will put here the value of 2 pi. So if we put the value of 2 pi, that is 20,000 into 2 pi minus 9,500 cos of 2 pi into 2, that is 4 pi by 2 minus 5,700 sin of 4 pi by 2 bracket complete. Now again we have to take minus inside the bracket. Instead of theta we will put here as a 0. So we will take here as a 20,000 theta, that is 20,000 into 0, that is 0, then minus 9,500 cos of 0 by 2 minus 5,700 sin of 0 by 2. Now we will find out what is the value of cos of pi, or we can say cos of 4 pi cos of 0 and sin of 4 pi and sin of 0, and we will put the value. So next term is 20,000 into 2 pi, that is 40,000 pi minus, now what is the value of cos of 4 pi? So cos of 4 pi is equal to 1. So if we take here
or if we put cos of 4 pi is equal to 1, then it will become minus 9500 divided by 2, and sin of 4 pi is 0, so whole term will become 0, so minus 0. Then in the second bracket we have to give minus sign, and in the second bracket again here is 0, 20,000 into 0, that is 0. Then if we put cos of 0, so cos of 0 is 1, so cos of 0 is 1, so what is the answer here? Minus 9500 by 2, and sin of 0 is 0, so whole term will become 0. So if we solve this bracket, it will become 40,000 pi minus 9500 by 2, and here minus minus will become plus, plus 9500 by 2. So these both terms minus and plus is getting cancelled, so what is the answer? 40,000 pi is the answer.
The work done per revolution. So from this work done per revolution we can calculate the mean torque. So what is the formula? So we know that work done per revolution is equal to mean torque multiplied by the crank angle per revolution. So here revolution we have to take as a 2 pi. So what is the crank angle in one revolution? That is equal to 2 pi, and here work done is 40,000 pi. So what is the value of T mean? So mean torque is equal to 20,000 Newton meter. So we have to plot this mean torque in this turning moment crank angle diagram. So on this vertical line we will plot here as a turning moment or torque in Newton meter, and on this horizontal line we have to plot here as a crank angle. So here we will put the crank angle only for half revolution, so up to 180 degrees. So we have to make here, or as per our convenience, we have to make here some equal parts of this 180 degrees. So at the interval of 45 degree, here 0, 45, 90, 135, 180 degree. So on this crank angle we will plot all these angles. And now T mean, that is mean torque, is 20,000 Newton meter. So I will take here with scale, the number is 20,000 Newton meter. So I will write here as a 20,000 Newton meter, and this is the mean torque, that is T mean. So in this way this line is plotted. Now what is the first question? So first question is that we have to find out what is the power developed. So how to calculate that? So we know that work done is equal to T mean into theta. So if I divide both sides with time t, so work done per unit time means what? It is nothing but power. So W by T, which is equal to T mean into theta by T. So theta by T means what? Theta by T, that is angular displacement by time, which is equal to angular velocity omega. So if I put here omega, then we have to take here P is equal to T mean into omega. So for omega, the speed is given. So speed in RPM is given for this crank. So if I put here value of n, so omega, how we can calculate? From the given data, that is 2 pi n by 60, T mean is 20,000. Then what is the value of P? That is 20,000 into 18.45, which is equal to 377000, and what is the unit is watt. So this is the answer of first question. Now we will find out what is the value of torque at different angles, that is angle is 0 degree, 45 degree, 90 degree, 135 degree and 180 degree. So with the help of calculator, if we take theta is equal to 0, then here this is the equation of torque, that is sine of 2 theta, that is sine of 0, and sine of 0 is equal to 0. So this whole term will become 0. And what is the value of cos of 0? So cos of 0 is 1. So this 20,000 minus 7,500, which is equal to 14,300 Newton meter. So we will plot here one point at this 0 degree angle, 14,000, that is it is below the mean torque. So I will plot here 14,300, and this is on the 0 degree. Then in the same way we will move for the next angle, 45 degree. So for 45 degree, 45 into 2, that is 90. So what is the value of sine of 90? That is 1. And what is the value of cos of 90? That is 0. So cos of 90, this whole term will become 0. Here is the value of 120,000 plus 9,500. That is 29,500. So at this 45 degree, the value is above this. That is here we will select point, and here value of torque is 29,500 Newton meter. Now 90 degree, we will take 2 theta, that is 180 degree. So sine of 180, that is equal to 0. So this whole term will become 0, and cos of 180. So cos of 180 is minus 1. So if this cos of 180 is minus 1, so this minus minus will become plus. So 20,000 plus 7,500. So if we take here 20,000 plus 7,500, that is equal to 27,500. So I will plot here 27,500 Newton meter. So now this value we have to plot. So it is above this 20,000. So again I will plot here one point for this 27,500. Now in the same way we have to take theta is equal to 135 degree and theta is equal to 180 degree. So when theta is equal to 135, the value is 10,500. So this 10,500 is below this mean torque. So we have to take, so I will take randomly one point here, and that value is 10,500. And again for 180 degree value is 14,300. So for 180 degree I will select here one point. So these points are selected. Now if we join curve, then if we observe, so I have to join this point. So if I join this point A, I will say this is the point A, point B, then here is the point C, point D, and this is the point E. So I have to join this point A towards point B. So how to join? So for that there is the intersection by this line of mean torque. So that at the point of intersection where there is the mean torque, we have to find out the crank angle. So I will join these points. This is the point A, then B, then C, here is the point D and E. So this is the curve. So this is the formation of curve. Now we have to find out the crank angle in such a way that what is the value of angle theta when there is the mean torque. So this is the point of intersection. So this point of intersection we have to find out. So when our torque equation is equal to mean torque, then we will get that value of angle theta. So I will make here, what is the equation of torque? 20,000 plus 9,500 sine of 2 theta minus 7,500 cos of 2 theta, which is equal to what is the mean torque? That is 20,000. So when we equate this, then our equation will become 9,500 sine of 2 theta, which is equal to 7,500 cos of 2 theta. So I will take theta on one side, that is theta term on one side, and all the other terms to the other side. That is sine of 2 theta by cos of 2 theta, that is tan of 2 theta is equal to 0.6, that is 7,500 by 9,500. So what is the value of theta? So with the help of calculator, suppose we calculate here, tan inverse of 0.6 is 31 degree, and that's why theta is equal to 15.5 degree. So this 15.5 degree is after 0 degree. So I will say that here is the point of intersection, and suppose if I extend this point on this crank angle, then here is the 15.5 degree. Here this is the point of intersection. Now in the same way, if we observe, there is another point of intersection in between 90 degree and 135 degree. So I have to take here this point of intersection, that is 90 plus 15.5, that is 10.5.5 degree. So if I extend this point on this crank angle, so what is the value of this crank angle? That is 105.5 degree. So in this way we have to find out the point of intersection on this mean torque, that is covered by this curve. Now we will find out what is the maximum fluctuation of energy. So this maximum fluctuation of energy is the area above mean torque. So this is the line, that is mean torque, and what is the area above the mean torque? So here with this curve that I have shown the area with the help of the red marker. Now we have to find out this area. So how to find out? We have torque equation, and we also have what is the angle difference in between this baseline. So baseline is the distance in between this point P to point Q. So at this point P, what is the crank angle? 15.5 degree. And what is the angle at point Q? That is 105.5 degree. So this is the limit that we have to give for this torque equation, and we have to find out the area. So for this particular area, we will give here integration of theta P to theta Q in the bracket T minus T mean d theta. So why this is T? So T is the maximum torque for this curve minus this is the mean torque that we have to take, and here is d theta. So now we will put the value of theta P, that is 15.5 up to 105.5 in the bracket. What is the equation of torque? That is 20,000 plus 9,500 sin of 2 theta minus 7,500 cos of 2 theta minus mean torque. So mean torque is 20,000 and outside the bracket d theta. Now if we observe this 20,000 is getting cancelled. So if we solve this, the integration, that is integration of sin of 2 theta d theta, that means minus cos of 2 theta by 2, and this 9,500 remains as it is. And what is the cos of 2 theta d theta? That is sin of 2 theta by 2. So here minus 7,500 sin of 2 theta by 2, and outside the bracket we have to give the limits, that is 15.5 up to 105.5. So how to solve this? So first we have to put here instead of theta 105.5 in this both the value of theta, and then we have to calculate, and then again we will plot the value of theta is equal to 15.5, and we will find out the value of this bracket. Then we have to take the difference in between these two values, and what is the answer? 11,078 Newton meter. So this is the maximum fluctuation of energy. Now we will find out what is the coefficient of fluctuation of speed. So if we observe, it is given that the total fluctuation is 1% of the mean speed. So 1% means what? 1 by 100, and that is equal to 0.01. And mean speed we will consider here as a omega. And what is the total fluctuation? So total fluctuation is in between the difference in between maximum fluctuation and minimum fluctuation. So maximum fluctuation we will consider as a omega 1, and minimum fluctuation we will consider here as a omega 2. So we can say that what is the meaning of this given equation, that is omega 1 minus omega 2, which is equal to 0.01 omega. And if I write here omega 1 minus omega 2 divided by omega, which is equal to 0.01, and this is the equation for coefficient of fluctuation of speed, that is Cs. Now we will apply the formula for maximum fluctuation of energy in terms of kinetic energy of flywheel. So we have formula maximum fluctuation of energy is equal to 2 into kinetic energy of flywheel multiplied by coefficient of fluctuation of speed. So what is the kinetic energy of flywheel? So if we observe in the linear motion, kinetic energy is equal to half mv square, but flywheel is rotating. That's why we will take instead of m, that is mass moment of inertia I, and instead of velocity we will consider here as a angular velocity omega. So our formula is, that is maximum fluctuation of energy, we have calculated 11,078, which is equal to 2 into half I omega square multiplied by coefficient of fluctuation of speed, that is Cs. So value of Cs that we have calculated 0.01. So this 2 and half is getting cancelled, and value of omega. So rotational speed is given, omega is equal to 2 pi n by 60, and that is equal to 18.85. So we have to take its a square, and from that we can easily calculate the value of I, that is the mass moment of inertia of the flywheel, and that is the answer of our second question, 3121 kilogram meter square. So this is the answer. Now we will move for the next question, that is the angular acceleration at theta is equal to 45 degree from inner dead center. Now if we observe this rotation of the crank, then initially the crank is at inner dead center, and after completing its half revolution it reaches to the outer dead center, and this crank is connected to this piston cylinder arrangement, and there is the reciprocating motion of the piston. So we have to take theta is equal to 45 degree from IDC, that is inner dead center. So we will consider at 0 degree at this inner dead center, so angle is 45 degree. Now angular acceleration, so for this rotational motion we have to find out the acceleration. So for linear motion we have one formula, force is equal to ma, that is mass into acceleration. So in case of rotational motion we have to take here torque T is equal to, instead of mass we will take mass moment of inertia, that is I multiplied by A, that is alpha. So this is the equation. So here the angle is given. So particular angle 45 degree is given. Now if we observe at 45 degree, here is the torque T. That is we have calculated 29,500. But we have to take the excess torque, that is the torque above the mean torque. So this is important point. While calculating this alpha we have to take here T excess. So what is the torque above the mean torque? So mean torque is 20,000. Now we will apply here what is the equation for this torque, because we have given the torque equation. So first we will calculate the T excess, that is T excess is equal to T minus T mean. So what is the value of T? So T is 20,000 plus 9,500 sin of 2 theta minus 7,500 cos of 2 theta, and what is the mean torque? That is 20,000. So this 20,000 is getting cancelled, so we will put theta is equal to 45 degree, and then we will get here 9,500 sin of 90 minus 7,500 cos of 90. So we will get here 9,500 Newton meter. So this is the calculation part. So from this diagram, because we have earlier calculated what is the torque at theta is equal to 45 degree. Here may be in question there may be the different angle. So this is the calculation part. So in this way we have to calculate the excess torque at any angle. And now we will apply this formula, that is T is equal to I alpha. So T excess is calculated 9,500. Then I is also calculated 3121. Then we will get angular acceleration alpha 3.044 rad per second square.